is day 2 in terms of teaching all your multiplication strategies in just 5 days. So in day 1, we focused on doubling. In day 2, it's all about our times 10 strategy and looking at the other strategies that build off knowing how to multiply by 10. And so the language that we're using to talk about multiplying by 10 is regroup each digit to the next place. Now, you might have noticed that it doesn't simply say just add a 0, because we want to actually avoid that idea of adding a 0 altogether. Firstly, because when you think about it, if you add 0, nothing, to something, you're just going to get what you had before. Adding a 0 shouldn't technically do anything. And while it seems like a really nice, convenient little cheat code, like 8 times it by 10, add a 0, it doesn't necessarily explain why that works. And look, if adding 0 is the only strategy students know to multiply by 10, it can set them up for misconceptions down the track. Because, for example, what happens if we've got a decimal, like 1.5, 1 and 5 tenths? If I wanted to multiply this by 10, adding a 0 isn't going to do anything. That's going to be the exact same number as it was before. And that's why it's really important that we're using this language of regrouping to the next place. So each digit has to move up 1 decimal place. And so we can show that using a place value chart. For example, here we've got 3 in the ones place, and so we've got 3. If we wanted to go 3 times 10, that means I need 10 3s. And so now that I've got my 10 3s, you can see that it's really just the same as 3 10s. And so I need to trade these blocks for 3 10s, and then regroup them to the next place. So now I can clearly see how my 3 times by 10 became 30. And so from this, we can see that I haven't simply added a 0, but my 0 has been created to hold the place from my 3 1s being regrouped over to become 3 10s. All right, let's do another example with a 2-digit number. Let's say I wanted 14 times 10. We need to think I need 10 14s. And there we go. We can see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 14s. But you can also clearly see that each place value column now needs to be regrouped into the next place. So our 10 10s will become 100 and our 41s will become 4 10s, leaving us with 140, showing that our 110 has now become 100 and our 4 1s have now become 4 10s. Each digit has been regrouped to the next place. And so again, if I wanted to show 7 times 10, instead of just simply writing that 0 at the end of it, I would say, well, 7's being regrouped to the next place. So our 7 1s will become 7 10s and a 0 will take the place in the 1s column. So at this point, I'd write a bunch of different numbers on the board and have students see if they can practice that multiplying by 10 using that language of regrouping to the next place. So the next strategy we're going to do is multiplying by 9. So for this, all we have to do is times it by 10 and then take away one group. So let's just say I wanted to multiply 3 by 9. I would start by timesing 3 by 10 first. And if I regrouped each digit to the next place, well, my 3 1s would become 3 10s, which would be 30. And so then if I want to find what 9 groups is, I simply have to take away one group. So I have to times it by 10 and then take away one group. So I have to, in this case, subtract 3 from my 30, and I know I'll be left with 27. So again, let's say I wanted to work out what's 9 times 6. First, I would multiply 6 by 10 using our regroup each digit to the next place method. So I know that my 6 1s would become 6 10s, which is 60. And so now that I've got my 60, I know I've got 10 groups of 6. But remember, I only wanted 9 groups of 6. So now I simply have to take away one of those groups. So I have to go 60, take away 6, which is going to leave me with 54. So again, give your students a dice, send them off, and they just have to continually roll that dice and try and practice multiplying by 9. And if you've got some students that need an extra challenge, they can simply roll 2 dice. And that's the beauty about these strategies, is that once you learn the strategies, you're not just limited to single digit multiplication, you can multiply any single number by 9. So now that we've practiced our strategy for multiplying by 9, it's time for our other strategy that also still builds itself off multiplying by 10, and that is multiplying by 5. Because to multiply by 5, all we have to do is times it by 10 and halve it. So to show you how this strategy works, let's say I wanted to work out 5 times 4. I first multiply by 10 to get 10 4s. And so I've got 10 4s 40. And then I simply halve that number to get 5 groups, in this case 20. And you might be asking, well, can't my kids just skip count by fives instead of worrying about this halving business? Because, most of my students can skip count by fives and they could have just gone 5, 10, 15, 20. And yeah, look, that's totally fine. But the good thing about these strategies is that they're more robust for dealing with larger numbers and definitely more scalable. For example, if you ask me to find 5 times 82, I certainly don't want to have to skip count by fives 82 times. While here, I can use my strategy times 10 and half. 82 times 10 will be 820, and then half of 820 will be 410. A lot quicker than skip counting. So then once again, after you've modelled, give the students some dice, they go and roll some numbers and practice multiplying by 5, by timesing by 10, and halving. And then finally, get your students to add their new strategies for times 9 and times 5 onto their sheet. And so you can see that at the very end of day 2, we've already covered nearly all of our strategies.